All. This is Dr. Mobeen Sayed from drbeen.com. Welcome to one more show. So the discussion today is about the mu variant. There is a lot of buzz in the media about it. So here is the summary of this. Mu variant has not proved to be very, very dangerous like Delta was. And mu variant in the presence of Delta could not take more land compared to the Delta itself. I'm sorry to use the word land. It could not spread more. And Delta is still the dominant one, except the countries Colombia and Ecuador, where mu variant has gained place. It has spread more than Delta, 39% and 13%, but worldwide, mu variant has actually declined in its prevalence. The end of the August, WHO declared it a variant of interest because of the spike protein mutations that are immune escaping mutations like other variants. However, there has still been no proof for this to be more contagious or more lethal than Delta. So let's look at the data together. This is the summary of it. Let's start. So you would, I think, like this. So spent a lot of time today drawing this one. So this is the alpha variant, original variant. This is Delta, still the bad one, and this is mu variant. This variant is thought to be of concern, not concern in technical terms, but of concern generally in media, but it really has not proven, and it is a good thing that it has not proven to be more dangerous. So let's look at it. So these are the gifts of humanity. We'll continue with them. Let me quickly show you the references as well, so that you can read them up by yourself too. If I make any mistake, you can see them there. So this is drbeen.com. This is WHO's 31st August announcement, in which they declared mu variant as a variant of interest. If you see here, they're saying SARS-CoV-2 variant of concern, alpha, beta, gamma, and delta, which includes updates on the graphic distribution of the variant of concerns. And then they said a newly classified variant of interest, mu. So here is their announcement. In this, here is a little bit about the mu variant. We'll look into that. Then this is the tracking of the variants and the variants of interest versus variants of concern. The basic difference for WHO, the variant of interest is something that they observe the variant itself to be changing in its phenotypical structures or structure or function, or lethality or contagiousness. That is the variant of interest. Variant of concern is something which has actually caused enough damage and done enough change that the social behavior plus the medical therapies may need to be adjusted, for example, vaccines. Then it becomes variant of concern. So mu is still a variant of interest. This is another article. I really like it. This is, again, WHO's PDF that I showed you. This is next strain. So here I would like you to pay attention to this part. So here, this red one, 21H. I know it is a smaller screen, but this 21H over here is the mu variant. And if you see here, this area down here, this red one, is the prevalence of the mu variant compared to all of these. This top here, the green one, is the Delta variant and its branches. So if you see here, when I hover the mouse over the red one, the mu variant, there's a very small streak. And this is possibly the area of the Ecuador and Colombia. That is all where this variant is. And remember, this variant was found in Colombia in January. So it had enough time, almost 8.5 months. So if it was more dangerous, if it was more contagious, it would have dominated by now. Compare that to Delta. Delta started somewhere in the late 2020 and it became dominant very fast and it continues to be dominant. So if mu variant was as bad or worst, then we would see it to spread faster and worse as well. This is a good article about the cluster of the, there's a study here from Rome that shows that mu variants efficacy with the vaccine and what is the difference in that. This is Wikipedia. Again, if you don't want to read it from Wikipedia, you can read from other places too. This is just simple, easy access, free access. This is Delta. This is a coronacovariants.org. Here what they have is various variants and their spread. So I really like the data that is present here. We'll look into that as well. This is covariants, various variants and their spreads and the percentage of their spread. So we'll look into that a little later. And finally, this is CDC. CDC has not even considered the mu to be a variant of interest so far. So today is 9th of September. So now with this background, let's do this. We'll go over a summary. Summary will be done in 5-10 minutes and then you are home free. If you wanted to discontinue watching after that, that is fine. Then we will go into a detail of the mutations and which mutation may be bad and which mutations are just simple mutations. So let's start with the summary. Potential for immune escape. So mu variant does have mutations which other variants of concerns have as well. So it has that potential for immune escape similar to, let's say, other variants. It was first detected in Colombia in January 2021. This is important to see that January is the detection time, and since then till now, there is a lot of months and it has not dominated. More than 0.1% of the cases worldwide are mu. Compare that to the Delta, which came in late 2020, and now that is a dominant one. August 31st is when WHO declared it the variant of interest. Mu variant had started in Colombia. In Colombia now, 39% of the cases are of mu. This was January in Colombia. So even within Colombia, it is not spreading that fast. Then it has spread to Ecuador as well. It has spread to 39 countries. Ecuador is another country where there is 13% cases are mu. More than 30 countries, 39 countries, 0.1% prevalence worldwide. 39% cases of Colombia are mu, 13% in Ecuador. So that is its prevalence. Now, about the mutations. It does have mutations that are also present in other variant of concern. So based on those mutations, what one could say this is a variant of concern as well. However, even with those mutations, it has not really spread faster or dominated. And I'll explain my theory for why it did not. I'll show you some changes in it, which I think caused the variant, this variant mu, to not spread faster. So global prevalence has declined. That is according to WHO, and I'll show it to you. A study in Rome. So this study that was here, this study. In this study, the author, so this is from Rome. This is a very tiny study, 37 cases. So what they did was the researchers, they took convalescent plasma from 37 people. They took their antibodies, which were against Delta, and then they attacked mu variant with those antibodies. And these antibodies were not against Delta. These were for Pfizer-BioNTech vaccine. And they wanted to see if those antibodies would attack mu variant as well. And they saw that the efficacy stayed robust, although significantly reduced. So now here, when we say significantly reduced, that is not an English word significantly to be used. Instead, statistically, significantly reduced mean efficacy reduction was proven with statistical significance. So, but it was still robust. So that is the only one study available so far which does not show much of a concern. Although the authors say that, hey, we should continue to look at the genomes and sequences and changes, and here is their data. Now the details, the changes. Let's look at, before we go to the changes, I want to show a couple of things. First, let's look at the WHO side. WHO says, and so if you are just looking for the summary of the variant, we're done. This is it. Not that dangerous. It is, I shouldn't say not that dangerous, not that contagious. Contagious means spreading. And the world dominance is not there compared to Delta. Now, looking at some details. Here is the WHO. WHO says, based on the latest round of assessments, B1621 and B1621.1, these are the classified as variant of interest and given the label mu. Mu is a 12th letter in the Greek alphabet. This includes the descendant Pango lineage 1621.1. This variant is known as 21H in next strain nomenclature, and that is what we saw that over here. This is the, where is the next strain? One second, please. Here is the next strain, and this is mu or the 21H. The mu variant has a constellation of mutations, and we'll go over them, that indicate potential properties of immune escape. So this is the wording they're using, indicates potential properties of immune escape. Preliminary data presented to the virus evolution working group shows a reduction in neutralization capacity of convalescent and vaccine sera, similar to that seen for the beta variant, but this needs to be confirmed by further studies. So they say either convalescent plasma or the people who have been vaccinated and have antibodies because of the vaccine, they both show reduction in controlling mu. But the letter that I just showed you, let's look at actually the words in that letter. They are using the following narration. Where is it? Here. So they're saying, here we demonstrate that neutralization of SARS-CoV-2 B1621, that is the mu variant, lineage was robust, even if significantly lower than that observed on SARS-CoV-2 B1. So that is the original Wuhan. Our findings underline that vigilance of SARS-CoV-2 genomic evolution is fundamental to limit the spread of new SARS-CoV-2 lineage to different countries. And then they've talked about some of the mutations, and I'll talk about them as well. Now, let's go here for a second to co-variants. So again, we are doing the details. So I'm hoping that you are comfortable with looking at the details. So if I go here per variant, if I click here, and all of these links are present in the description. This is a beautiful way of representing the graph. So let's look at, this is alpha. So alpha is the original Wuhan variant. And here, if you hover the mouse over any place, what it shows is the frequency of the cases. So one being all cases of this variant. And then a smaller percentage, for example, 0.96 is 96% cases. So if you see here Delta, and please remember this is the timeline. So December, February, April. So if you look at, now alpha is gone. So if you look at August, what is the prevalence? Cambodia 0.66, 66%, Japan 14%, Thailand 10%, Ecuador 0.08%, and so on. So this is now, alpha is really declined, gone. Beta, if you see here, this is also quite low. Gamma is quite low as well. This is Delta. And if you see, Delta has risen up and stayed up. And mu came up in January, and mu could not dominate. If mu was dominating, then Delta would go down and mu's graph will go up. So if you see here, let's go to the 23rd August and see majority of the countries, majority of the cases are Delta. So 1 means 100% of the cases, 0.99 means 99% of the cases, and so on. So if you see here, delta is still sticking to the top. If you look at kappa, almost came and went, eta came and went, iota, lambda, and here is mu. So if you see here, mu has actually risen. You see this number? This number, the one that is rising, that is for Colombia. So in Colombia, for sure, 39% of the cases are mu. But for the worldwide, it could not dominate while given enough time. It's a good thing. I'm not saying that this is a bad thing that has happened. It's a good thing. So here again, it would have been interesting if mu was less lethal. Let's say it had a smaller window of time to cause the symptoms. That means it was more contagious, it was more infectious, it was more transmissible, it was more strongly binding to the ACE2 enzyme. And that means as soon as it lands, it causes the symptoms and it causes the immune system to respond and gets killed very fast. Then it would have zipped through the society fast enough and created immunity. But of course, we don't want a virus to do this. Still, coronavirus with an incubation time is a dangerous thing because it causes people to not knowingly shed. So here, it could have been better if it was faster but less lethal. That didn't happen. So that is mu, and you can actually just have a quick look at others as well. So there is this EU1, it came up and went away, and so many others. There is Pelican, and there is Drbeen, and blah. So at the end of the day, once again, the two important variants to look at, delta here, staying at the top, staying as dominant. And mu came up in one country at least high, and then nothing for the rest of the world. Another thing that is interesting is that if you go down here, these are all the important mu variants, and you can actually click on any one of them. For example, if I go here and click on this one that says mu, then here on the right side are all the mutations. So that is also an interesting thing. So I'm going to go back here to look at the mutations now. Okay, so it is actually a simple graph. So don't be put off by all of this noise here. 21 mutations in total. 9 mutations on spike protein. The remaining mutations on the open reading frames before and after the spike protein, also on the N protein amino acids as well. So let's start from this side. On this side, this is the beginning of the genetic material for the SARS-CoV-2. Open reading frame 1AB. It has the following changes. So we've been looking at mutations. We know that the beginning letter is one amino acid. Then this is the position of the RNA in the alphabets or the letters, and then or on the genetic string. And then this is the amino acid with which the other one is changed. That is the mutation. But what is interesting are these for us. These mutations, for example, in the PL-PRO, that is 3-chymotrypsin-like protease. So there are 2 changes in the enzyme that is responsible to help the variant, the virus, the coronavirus, the SARS-CoV-2 to replicate. And to me, it seems like these 2 changes are negative for the variant. Similarly, this is also a very, very interesting one. Look at this one, RDRP. There is a mutation on RDRP. RDRP, RNA-dependent RNA polymerase, that is the enzyme that also helps the virus replicate. And there is a mutation there as well. And I think that mutation may also be negative for the virus. Now, if there are drugs, for example, ivermectin attacks RDRP, zinc attacks RDRP, Merck's new molnupiravir attacks RDRP, or a similar mechanism, it kind of tries to disable RDRP by providing fake material. And if the RDRP is changing, this could be an escape as well. So I could be here correct or totally wrong as well. I could be wrong if these mutations are helpful for the for the enzymes to become more efficient in replication. And I could be correct if what I'm saying is that the mutations are causing the enzymes to become less efficient, and if that is true. To me, it seems like the way the variant tried to get higher in spread, in prevalence, and then just declined, I think its enzymatic system is not very good. So it has a problem with its enzymes, and there are mutations there. That's my thought. I may be wrong. Now let's look at the spike protein. This area is a spike protein. On the spike protein, if you see, spike protein is a genetic material. So we're looking at the genetic material here. In the beginning, we have N-terminal of the spike protein. Then we have receptor binding domain of the spike protein. On the receptor binding domain, there is receptor binding motif. And then we have SD1 and SD2 portion of the spike proteins. Let me look at these 4 mutations first. These are the mutations that are also found in other variants of concerns that have become more contagious. So we have been talking about 484 mutation for a long time. We have been talking about 501 New York. 484 was the mutation that was in the beta variant, then South Africa variant, and then Delta. 501 was the New York variant. So these are the changes on the spike protein that make it more efficient. But then there are other changes as well. For example, on the receptor binding domain, there is a new change, R346K. And then if you see here, this is interesting just to see the mutation. There is a change here at 144 and 145 position where there is a new amino acid has become inserted. Now, would it help the virus to become more, to escape more, or reduce the efficacy of the immune system? May that be from the natural infection or from the vaccine? We don't know. But this is a new insertion. There is a new amino acid inserted in it. And that happens as well in the mutations. And interestingly, this virus, this mutation, mu, has that. Once again, keep in mind that with all of these changes, this variant could not dominate. So these changes, as much as the virus tried, they are not the ones that have helped it too much. Now look at this side. There is an interesting change in here as well. On the open reading frame 3A, there is one change here, one amino acid at the position 57. Yes, 57 is changed Q from H. But look at this. There are 2 amino acids that have become deleted. And why is that interesting? Why that is interesting is this. So let's say there was an amino acid A, amino acid B, C, I'm just making up some numbers, D. Let's say these were the amino acids. And then let's say out of these amino acids, this one and this one got deleted. Then we are left with A, C, D, and maybe some more amino acids next here. What has happened in this virus's case, in this variant's case, is, I shouldn't laugh at the variant, it can become upset with us. The case is that because of 2 deletions, the remaining amino acids, let me give you an example first before I continue to explain here. Imagine if we have written a sentence here. Let's say one of the words that we use in medicine, I'm just trying to find a long name, long word, dysdiadochokinesia. This is a word. This means abnormality of the kinetic movement because of the damage to the brain tissues. Okay, so dysdiadochokinesia. Imagine we can delete some letters in here, and then the remaining letters can connect together to make a new word. That is what happened here. When these 2 got deleted, the remaining came together and they became a stop codon. Stop codon is what? When a gene is expressing. So when a recipe in a book from a genetic material is being read, normally what happens is a gene has a start, just like a recipe. For example, let's say we make chicken tikka. So I do not know how to make a chicken tikka or something else. So let's say start here. The recipe says start here. This is the title of the recipe. Then the recipe has a number of instructions. And then there is an end of the recipe which says, okay, this is the end. So normally the chef who is going to use that recipe to cook something, they would start from the start and then they'll go over the instructions and then they would stop at the end. We can call this end as a stop code in genetic terms. Sometimes there are genetic changes that occur which create artificial stop codons. And instead of the chef now going through the recipe, if we unfortunately create, in this case it would be better for us, create a stop codon here, now the chef is only going to go over this part of the recipe and try to cook that much and stop where this new stop codon has appeared. And now that chef is going to skip over all the remaining part of the recipe, which was necessary to make the good recipe, and now the thing that is cooked is useless. So here, the stop codon has appeared where it was not because of these two deletions. Now, could it be a good thing? It could be. For example, let's say this much of the recipe is actually more dangerous. It's a poison. But if you add these contents to it, it becomes less poisonous. Then having a stop codon here would actually be dangerous because now we are making poison. On the other hand, majority of the cases, when a stop codon appears earlier than where it should be, most of the time the recipe gets bad, and the protein that is made from that bad recipe is usually a damaged protein because it gets trimmed early on. So this variant actually has a number of mutations that, in my opinion, again, just medical mechanism point of view, in my opinion, it kind of makes it less efficient and more prone to fail compared to other variants. So this is the discussion. I hope it makes sense. Once again, I have all the links that I use the information from in the description. Please do me a favor, look at those links as well. What did you think? So there is lots of news cycle nowadays. What did you think? Did you think that mu variant was actually gaining ground? There are news from Japan and news from other countries. Or did you think that it was not the most stable and efficient one? Anyways, with this, thank you very much for going through this with me. Please like, subscribe, and share. If you would like to support this work, there are 3 links in the description. One is to buy me a coffee. The other one, and I have my coffee with me today. Other one is to support me with PayPal, and the third one is to be a patron. Thank you very much. I am going to come back in 5 minutes, but instead of doing a chit chat, I wanted to go over Israel's data as well, because that also has a lot of news cycle nowadays that the vaccines, are they effective there or not? So we're going to look at the Israel's data together. Thank you very much and see you soon.